Alright kids, so we're back with metals and we're going to do the basic reactions that metals undergo and electron transfer. Now, all of these, they tend to be done with, like we're talking about experimental data here basically, empirical experimental data, and what that means is we can see, well, you're going to see when we talk about acids, we talk about dilute acids, and the reason we do that is because we're talking about experimental data, not just the theory of it, like we're talking about actual results. Okay, so let's move on. So, well, first off, these are the dot points we're going to cover today. The acid and reactivity, the activity and reactivity of an element. Now, reactivity of an element is how quickly it reacts, how readily it reacts, how easy it is. Reactivity can be determined experimentally, and we do that as a function of time to react completely, or reaction rate. So that's the function that we set that curve up with. Now, if something is readily reactive, we call it an active element, so it's activity series, the activity scale. If something's unreactive, we call it either inert or noble, and these are inactive elements. So there are some noble gases, but there are also some noble metals. Like gold tends to be a noble metal, and that's why it's wonderful for jewelry. Is it doesn't react with the environment, doesn't oxidize. It's fine. Okay, so metals and water. Okay, you've seen this one over here, and this is sodium. Okay, and you actually, one way to tell it's sodium is the bright purple, and that's common to sodium across the board. So we have a metal plus water gives hydrogen gas, and a hydroxide for highly active metals, or oxides for less active metals. So metal plus water gives you hydroxides or oxides and hydrogen gas. For example, with sodium, we have sodium plus water here, and this is the one you've done, and it makes sodium hydroxide and hydrogen gas. Now, it explodes. The reason it explodes is that it's producing hydrogen gas, and this gives off also heat. So it gets really hot, and that heat reacts with the hydrogen and causes it to combust. So that's sodium and water. So sodium and water is sodium is very reactive. Zinc is less reactive. So we can't mix it with water and have it do anything, but if we mix it with steam, it will react then, and that gives us hydrogen gas and zinc oxide. Alright, so the reason the steam works as opposed to the water is that it's just hotter. Alright, so it has more energy in there. So here's our reactivity of metals. So we've got sodium and these guys, they react with cold water. Magnesium needs to react with hot water, but aluminium, zinc, and iron, they react with steam when they are red hot. So there's a lot of energy already in there. And we come down here to the bottom, and these guys, they're inert. They don't react, and they're some of your noble metals. Okay, so when we react a metal with oxygen, we're talking about essentially heating it up in a Bunsen flame and then putting it into a gas jar full of oxygen. So it looks like this. We heat it up. This is a gas jar, by the way. It's actually a pretty poor gas jar. We've got better ones than that. So we heat it up in the Bunsen flame, and then we put it in the gas jar full of oxygen, and it glows brightly if it reacts with oxygen. So they either form oxides or peroxides. So peroxide means O2, and let's look at it. So if we've got calcium plus oxygen, the calcium's a metal, plus oxygen gas give you calcium peroxide solid. Now, if you see in our word equation, we've written the states next to it. Now, I know metal's not a state, but you get the point. That's something you should be doing in a word equation. And here we go. So we've got calcium plus oxygen gives you calcium oxide solid. Mercury. Now, mercury metal plus oxygen gas gives you mercuric oxide, or mercury 2 oxide. All right. And here we are. So as we see down mercury, it becomes coated with a layer over as it heats. It doesn't combust rapidly. It just slowly oxidizes or corrodes. Right, so we've got burn rapidly with oxygen. If powdered, aluminium, they think that was a big part of the reason. They think that was a big part of the reason that the Hindenburg had the drums, was that it was coated in a dope made out of powdered aluminium. So that plus the hydrogen and the whole thing burned extremely well. these guys down here, they oxidize slowly, and again, silver, gold, no reaction at all. Alright, so a metal and an acid. So we covered this before. We know metal and acid gives us hydrogen gas and a salt. Now, reactivity, acid plus metal can be dangerous. Reactive metals create heat and and hydrogen gas, and that's explosive. So when we talk about these, we talk about things we can do in the lab, and therefore we use the word dilute, however you want to say it, dilute hydrochloric acid. So here we have zinc plus hydrochloric acid gives you zinc chloride plus hydrogen. Now you need to be able to talk about these in terms of half equations, okay, and then the ionic equation down here. So we've got the zinc. In this side here, it gives off 2 electrons, becomes positive. On this side, hydrogen has already given off the electrons, and then it combines on the next side to be a molecule. So this one goes from being ionic, and you can see that it's ionic there. It's in an ionic species, whereas this one's elemental. Goes into this side. Now this one's an ionic species, and this one's elemental. Chlorine doesn't make it into the mix, and the reason chlorine doesn't make it into the mix is because according to this, it stays the same. It stays ionic. It's ionic there, and it stays ionic there, so it doesn't actually change. Alright, which I've just said. So the activity series of metals, the order of reactivity we call the activity series of metals. It's determined experimentally, and we can only do some of that in a school lab. The more readily electron transfer occurs, the more reactive a metal is. Okay, and that's simple as. So electron transfers can be summarized as half equations, which we've now done a little bit on. And this is our series. So if we look at it, it goes least reactive to most reactive. You should probably copy this down. It's going to take you a little bit of time. And you see this group here, they displace hydrogen gas from water, steam and acids, and they form hydroxides. These ones here, they displace the hydrogen gas from steam and acids, and you see that we're no longer dealing with they won't do it in cold water, and they form hydroxides and so forth all the way down. Okay, so that's it. I hope that makes sense. I hope it wasn't too confusing. Don't forget to bring questions in, make your flashcards, etc., and I'll see you in class.